So, Dr. Eric Christian, tell our listeners a little bit about yourself, how you got here. During your childhood, were you dreaming of being a scientist, or was there something that you saw or experienced that it inspired you?
I'm unusual in that from a young age I decided what I wanted to be. I was really good at science and math from the very beginning. And the Apollo landings, I was 8 years old, and that made me decide I wanted to work for NASA. I wanted to be a scientist and I wanted to work for NASA. Didn't want to be an astronaut, but did want to explore space, so so I went, undergraduate in astronomy and physics, with a minor in computer science at University of Pennsylvania, and then got into Caltech for grad school, which is one of the best places in the world.
Yeah.
Uh, Worked on both balloon astrophysics instruments and then the Voyager deep space probes. Um, so got a degree, PhD in astrophysics, and immediately started working for NASA as a contractor. So I started working for NASA right after I got my PhD, first as a contractor and more recently as a government employee, but basically got my dream job right out of college. I like building hardware. I'm good with my hands. I'm good in the lab, and so I design and build scientific instruments for NASA and fly them on rockets. It's the coolest thing ever to watch a rocket with your hardware launching into space. So,
I can imagine. So, what's the fascination with the sun? How did you end up studying the sun?
so, sort of came gradually. I actually started studying what are called galactic cosmic rays, particles that come from supernovas and black holes and neutron stars and distant parts of the galaxy. Um, but many years ago, I started working on a spacecraft called the Advanced Composition Explorer, or ACE, that now 20 years later is still working. Um, and the two instruments I was helping build on that, one of them was designed to look at galactic cosmic rays, and one was designed to look at what's called solar energetic particles, which are high energy particles coming from the sun that are accelerated in solar flares and coronal mass ejections. And so generally, I joke that I've lost energy with time, because I started working at really high energy particles, and I've sort of moved my way down to much lower energy particles as time has gone on. But at lower energies, there's a lot more of them. So there's lots of fun science to do. So I've always been adaptable and gone where funding and missions, and always found interesting work to do.
So, tell me a little bit about this mission we are working on, the Solar Probe Plus. The headline says it's going to touch the sun. Is it really going to touch the sun?
So it was recently renamed the Parker Solar Probe after Gene Parker, who's the first person to come up with a theory for what's called the solar wind. Before we even launched any spacecraft, he by looking at comet tails, figured out that the sun was blowing this wind off in all directions. And yes, we are going to touch the sun. We're going to get to within 4 million miles of the surface of the sun, much closer than any other mission, like 10 times closer than the missions we've sent to Mercury. And by going that close, we actually get into where the action is. There's a couple key questions that we have not been able to answer from our spacecraft near Earth.
Mm-hmm.
One is why the corona, why the atmosphere of the sun is much hotter than the surface of the sun. Normally, when you get further away from a fire, you get colder.
Right.
That's what everyone expects. So the surface of the sun is only about 6,000 degrees, yet the corona, this thin atmosphere around it, is a couple million degrees. How does that happen? There are theories, but we can't tell with all the cameras we've been able to put on it. We haven't been able to tell from Earth, and so we're going to get there into the region where the corona is still being heated, and so we'll be able to see directly what is heating the corona. The other exciting thing is the solar wind. So there's this, Gene Parker developed the first theory. This solar wind is a stream of particles that the sun blows out in all directions at a million miles an hour. And we don't know how they get accelerated. Once again, Solar Probe is going to be in the region where these particles are still being accelerated and be able to see for the first time what causes the solar wind. So the sun is really important to life on Earth, and understanding it and understanding how it changes is key to one of the key questions that NASA is hoping to answer.
Well, that's probably what some people are wondering is how are these studies and your discoveries after this vehicle visits the sun, the data that comes back, how does that help our life here on Earth? And what questions does it answer as far as, I assume, the formation of the solar system, right?
So it's not so much the formation of the solar system; it's the evolution of the solar system. The
Mm-hmm.
solar system formed out of a cloud of gas and rocks, and that condensed into the sun at the center and the planets orbiting it.
Mm-hmm.
But since then, the solar wind, the sun has changed. I mean, and it's going to continue to change, and it also is active. It has these solar flares and coronal mass ejections, and as we get more technology, we're more affected actually by the changes in the sun, especially the short-term ones, and even the long-term ones. Now we can study the sun and worry about whether it's going to get hotter, colder, etc. So we want to be able to predict what we call space weather, like we predict Earth weather.
Mm-hmm.
So. But we're way behind. It's like we're 50 years behind where the prediction of terrestrial weather is. Mostly because we just don't have the weather stations. We've got we're trying to predict the weather in the Pacific Ocean, having only 2 weather stations. That's tough to do.
Yeah.
But we're getting there. We're starting to understand the processes more, and like I said, what we want to do is predict it, because these solar storms, for example, can affect not only satellites in orbit, like your GPS, astronauts, especially if they get away from the Earth's magnetic field, which acts as a force field. But they can also affect us here on the ground. They can affect airlines, both communications, and give radiation to especially flight crews who spend a lot of time up at altitude and on polar flights especially. We're worried about, making sure that we monitor, their radiation dosage to keep them safe.
Mm-hmm.
Space weather can also affect the power system. Because storms can move the Earth's magnetic field. And when you have a moving magnetic field, you generate an electric field in long wires. And the longest wires we have are oil pipelines, which actually you can make batteries out of oil pipelines with these geomagnetic storms. But more importantly is that the power system is typically running for economic reasons at nearly full load. And if you get an extra load put in from one of these geomagnetic storms, you can blow a room-sized transformer and cause massive power outages. There was one in Ontario that was caused by a solar storm.
Wow,
and they don't have, go ahead.
That's incredible.
Yeah. And they don't have replacements for these big transformers. They just don't have a stockpile of them. It can take months to replace them. So a really big geomagnetic storm could do billions of dollars worth of damage to the power system. We want to be able to predict it, because if we can predict it, then the power companies can actually rearrange their networks so that they're a lot more protected from these storms.
Gotcha. So the solar eclipse on August 21st, NASA's ramping up, and I imagine you're keeping pretty busy with
Mm-hmm.
all the ongoings. There seems to be quite a few things going on, different kinds of tests that NASA is doing. The one in particular that seems very interesting is the WB-57 airplanes that are flying out of here in Houston from Ellington
Mm-hmm.
Field. It's going to be actually chasing the path of the solar eclipse.
So the time of totality, when the moon completely blocks the light from the sun, only lasts about 2.5 minutes.
Mm-hmm.
And people who want to study the sun, that's a very short period of time to take all the photographs you need, change filters, do everything that you want to do. So by flying along with the shadow in an airplane, one, you don't have to worry about clouds because they're all below you. So something like a third of the country on average is going to be completely clouded out for the solar eclipse. But in a plane, you don't have to worry about that. And by flying along with the shadow, you can make this solar eclipse last 4, 5, 6 minutes, depending upon how fast your plane is going. You can't stay with the shadow for the entire length of the United States because the shadow's moving at 1,500 miles an hour. But you can make your eclipse longer and get more science out of it.
Right.
And like I said, avoid the clouds.
So, what the W57 that experiment or what they're looking at, does it complement what you're going to be studying next year with the solar probe, or is this something completely different that they're looking into?
So there is science you can do from an eclipse that is hard to do from space. And that is that you can see the moon is almost a perfect block for the sun. The size is coincidentally just about spot on for the sun. And so you can see the corona, this atmosphere of the sun, down very close to the surface of the sun. We have artificial eclipses that we make in space with things called coronagraphs, but you need to put a bigger disk in. You need to block the sun in a lot more in order. There are physics reasons having to do with diffraction and scattering of light. So you can actually see the corona better in a total solar eclipse than you can from an expensive telescope that's launched into space. So solar probe is going to be actively in that region, but looking at the corona with telescopes does complement then the measurements we're taking, what are called in situ, in place in that corona. So yes.
Excellent. And I noticed also a lot on social media, NASA's announcing and other space-related media outlets. There's an app that people can download to their phones and provide data to NASA to help, along the path of what they're seeing and experiencing during the solar eclipse.
Yeah, so there's lots of interesting things that happen during an eclipse. The temperature actually changes, animals react, and so or the earth scientists especially, studying how the atmosphere responds can improve your atmospheric models for weather forecasting and stuff. And so they're asking people to measure temperature along the path and see how quickly the temperature drops and how quickly it gets warmer again. And so under different conditions for clouds and all that sort of stuff. So there's a lot of data. There's a lot of what we call citizen science that you can do with this eclipse. And even if you can't get to path of totality, which is only 50 or 60 miles wide, a partial solar eclipse is also kind of neat to look at. You got to protect your eyes and use proper eclipse glasses, but everyone in the United States can see the partial solar eclipse if they're not clouded out. So that's pretty amazing. This is the first eclipse like that where everyone can see it.
So what are you going to be doing during the solar eclipse, August 21st?
So this is going to be my third total solar eclipse. And I'm going to be doing mostly outreach. I'm not going to be doing science because I study not the visible light from the sun. I study solar energetic particles, which aren't affected by the eclipse. But working with the Exploratorium Science Museum in San Francisco, which is who I did my other two eclipses with, we're going to be doing a live webcast. We're going to be tying in to NASA TV's big webcast and TV show, and doing demonstrations talking about what we see. I'm going to be in Casper, Wyoming, which is one of those places that has a good chance of having clear skies. So, and I'm really looking forward to it. Total eclipses are amazing.
So NASA TV is going to have a live broadcast throughout the whole eclipse, and
yep.
it will be live streaming as well?
That's correct. It'll be live streaming and several other, there's a group called NASA Edge. It will also have a webcast, which at times will tie into the overall NASA show, and the Exploratorium will. So the NASA TV show will, especially as the eclipse moves across the country, jump to different places where they're seeing totality and really let you see, an hour and a half long eclipse across the entire country. So
wow,
that's going to be a lot of fun.
Yeah, I imagine you're going to enjoy yourself that day.
It's going to be a lot of work, but it's going to be very fun. My first total solar eclipse was in the Gobi Desert, and it was just awe-inspiring. I mean, as well as the crowds going, woo, ah, and stuff.
Yeah.
The whole light that you see just looks very different than anything you expect. So you see the sunrise all the way around you at the horizon, which looks weird. And the light on the ground is, you see sharp shadows, but it's dim. Your eye notices how dark it gets and stuff. And my first impression was that it looked like the old B-grade westerns where they filmed during the day, but they put the filter on to make it look like it's night.
Right.
And you can see that's what it looked like. It looked like an old B western. Just a very strange environment. The animals react, and it's just wild,
Wow.
amazing.
Well, we'll all be certainly looking forward to it and see all the exciting ongoings on NASA TV and media outlets for sure. So, what's your recommendation as far as youngsters that are, let's say, in college now or high school? What is NASA looking for in respect to heliophysics or in the careers that you've worked in? Because I imagine there's things you learn at school, but when you start your career and you start working at NASA, there are things that you learn about that they didn't necessarily teach you at school.
So NASA hires a lot more than just scientists. I mean, engineers, managers, financial people. So there's lots of jobs at NASA. If you want to work for NASA, you should definitely try, no matter what your skills and interests are. One of the amazing things about NASA is that there are a few places in the world where pretty much everyone who works here wants to work here. So it's NASA. I mean, it's
Yeah.
so the quality of people we get is just tremendous. Um, I would I would say the thing I've learned most that they didn't teach me in school was to be flexible. There's lots of interesting things to do. From as a scientist, I haven't stayed focused on one area of science when there have been opportunities in other areas, especially similar areas. It's all interesting. I mean, I love science. I mean, I considered being a geologist at one point. I might have been in planetary science if I had gone that route. I considered being, studying the oceans and stuff. I mean, maybe I'd be doing, astrobiology if I did that, because I always wanted to work for NASA. But there's lots of science that's fun and interesting.
Mm-hmm.
And depending upon your skills, and interests, I mean, I urge people to find a job they enjoy, because it really makes your life much better.
Yeah,
And
definitely.
that's the place to do it.
It definitely does make a difference. So, when you think about role models, let's say, or people who inspire you, or, things, maybe someone you saw while you were a kid that, maybe inspired you in some way. Is there someone that you would like to meet that you haven't met yet? And the reason why, and what would you ask?
So that's a difficult question, because I've met astronauts, I've met Nobel Prize winners. I would have said 10 years ago Neil Armstrong, because the Apollo landings, or one of the reasons why I work for NASA now. But I got to meet him actually before he passed away, and talked to him for about 5 minutes, and told him that he was one of the things that inspired me to work for NASA. He was a very gracious, humble man, and that was a lot of fun. So I couldn't think of anyone. I mean, I've traveled the world, a lot more than I expected to. I've met lots of people. And I've met my heroes at some level. I mean,
Not
I have
many
a
people
friend
can
who,
say that.
yeah, I have a friend who, repaired the Hubble Space Telescope, an astronaut, and so, 4 times.
Yeah.
So, it's been pretty amazing. I mean, there are historical figures that I might go back and want to talk to, but as far as my childhood heroes, I've actually met them.
Well, that's great. Not many people can say that. Thanks for taking the time to speak with us and giving our listeners an opportunity to hear all the fantastic things you're working on at NASA. We look forward to the solar eclipse, and good luck to you on Solar Eclipse Day.
Mhm.
Hope all goes well.
Clear skies. That's what we want.
Yeah, and I really hope you enjoy yourself, which I'm pretty sure you will. And I'll be following you guys on NASA TV.
Great. Okay. Thanks very much.